So first, thank you, Chris, for that introduction. And also, I really have to thank the MacArthur Foundation, Laurie, for your continued support of such an important area, and also Owen for leading the charge in the network on law and neuroscience. And then Congressman Fattah for everything that you're doing at the federal and the local level. And then I always like to give a shout out, so to Table 5, my colleagues who early this morning were willing to talk about some of the issues I'll be discussing today. So increasingly, adolescent brain research is being cited by courts and officials to justify more lenient laws and policies dealing with juvenile offenders. And Chris just mentioned a few, and also Laurie also highlighted these decisions at the level of the Supreme Court. But what I want to provide today is examples of research that I think help to explain in part why during adolescence we actually see this inflection in criminal activity, and trying to understand when the adolescent is capable of making a decision, and also when that ability seems to be more diminished, and how that's going to play a role in policy and the law. And I think to do this, what I'd like to really underscore today is what do we know now about the brain that tells us how it's different from not only adults, but also children. Because it's during this adolescent period that we are seeing this inflection in criminal activity and the children showing up in the system. And I want to preface the discussion on brain development by saying there are many individuals who would like to tell you that there is a hole in the frontal lobes of adolescence. But there is no hole there. I think Jeff gave a wonderful illustration of how there's these intricate processes that are going on and are developing. And for us to think of the frontal lobe as completely missing in the adolescent, well, it's definitely missing in children, and we're not seeing that inflection in criminal activity as much early as we are seeing it later. So trying to get a handle on that, trying to understand again when they can make decisions and when they can't. Now, Jeff highlighted that there is regional specification in the brain. That means that there are functions that are represented in different parts of the brain. It also turns out that these different regions of the brain have different developmental trajectories. And what I mean by that is some of them seem to be maturing or developing or being fine-tuned sooner than others. And I just want to illustrate this. If you just look at the cortical surface, this is the lateral view. And basically what you're seeing is any area that's turning blue is already reaching adult levels, but those areas that were sticking around for a while and weren't changing to that blue color are some of the ones to develop latest. So one of these areas is the prefrontal cortex. I think it's a lot easier if we look at a static image. Down below, you're looking down on top of the brain, and we see areas that are very important in the back for seeing, the visual cortex, and those that are responsible for just making a simple motion or movement right now, my hand moving, or if you were to wave. These areas develop before prefrontal regions in the brain that are so important in using sight and motion to guide goal-oriented behaviors, planned, rational behaviors. However, it's not all happening on the cortex. So there were questions about what's conscious, what's not conscious, what's sort of helping us control our behavior, and what's maybe pulling us to do things we may not want to do. And when we think about adolescent behavior, I'll have to say it's those systems, emotional systems, that reside deep inside the brain that are illustrated here in green and blue that are still changing from late childhood to adolescence. But they seem to be maturing before these prefrontal systems shown in fuchsia here. So that during this period of adolescence, there's a real tension or imbalance when you're calling upon both of these particular regions. So I've showed this here in a glass brain where the red area is these deep emotional centers of the brain. They learn about the emotional significance of cues. And then this area that's green are areas that literally project to these areas to quiet them down. And it's the communication between these systems that's continuing to develop during the adolescent period. So it's also important, and I think Jeff made this point, when we talk about changes in the brain, it's important that we can link them directly to specific behaviors. and one of the most important behaviors in the criminal justice system, as well as really just in terms of our development across the entire lifespan, is how well we can regulate ourselves. How much self-control do we have? And so a hallmark, really, of behavioral development is how well you can stop yourself from doing an appropriate action. I guess Jeff used going for pie or some dessert. I grew up in the South, so pie is a real seductive hue for me. And using that prefrontal system to wait till it's appropriate to have that pie, or not to eat multiple pieces of the pie as opposed to having dinner. But the way that we can measure this in the laboratory is to look at something referred to as impulse control. So I want to distinguish between our ability to control our impulses and also our ability to control our impulses when something in the environment is alluring or pulling our attention and pulling us to act upon it. So I thought, since it's early in the morning still, your coffee may not have kicked in from the coffee break if there was any out there, I was going to let you do a psychological experiment with me. And I apologize for those in the far corners because you probably aren't going to be able to see the stimuli as well. But basically, I want you to sort of get a feeling for how we measure this in the laboratory. And a go, no-go type task, we're going to perform the whack the mole task. And what I'd like for you to do is to say as loudly and quickly as possible, as you see these cues come up, I want you to say whack whenever the mole comes up, because you don't want him in your garden. He's going to eat your vegetables. And then anytime that you see a vegetable, like a it should be a carrot or a turnip. I grew up on a farm. My graduate students grew up in the city, so they think eggplant actually emerged from the ground. Really too funny to change it, right? You just really don't want to. So whenever you see an eggplant magically appearing from the ground, you don't want to squash it. It's miraculous, but too, it's a vegetable. So we want to see how quickly you can go. And again, whenever you see the mole, and he can be tricky, please just say whack as quickly as you can, and then nothing when you see the vegetable. Okay? You ready? Congressman Fatah, I know you're ready. Right? Okay. Well, you guys are really slow. Okay, so it caught a few of you. So what we do is we set up these really compelling tendencies to want to respond. It's not really that these little cartoon characters are that compelling to you. They are a little bit entertaining because we do have to get the children to perform the task in the laboratory. But now if I just show you the performance across the lifespan, plotting individual data points, what you'll see is how well you perform on this task, how well you're able to detect the mole as opposed to the vegetable and stop yourself when you need to. It's increasing from late childhood into young adulthood. But what I also want you to notice is that there are teenagers who are performing as well, if not better, than some of the adults. And so this is very important for us to keep in mind. Now, if I took this data and I put it into these simplistic bar graphs showing you how the group performed, and this is very important when we talk about group and individual differences, what we'll see is the number of errors you make, whether or not you're a child or a teenager or an adult, decreases as a function of increasing age. And if we had individuals perform this task while they were in the scanner for an fMRI experiment, as Jeff again provided a nice tutorial for, the whole bloody brain will light up, but what we're interested in is what areas in the brain are actually tightly coupled with how well you can perform this task. So we look at the brain activity when you're correctly performing the task, and then we look to see what area is correlated. And indeed, it's an area in the prefrontal cortex, and there are converging studies, lesion studies in non-human primates and the sort that show if this area is not working or it's not there, it's very difficult to inhibit a response. But what I'd also like to point out in this slide is there is nothing special about adolescence in this slide. Children look worse than adolescents. So how can we understand when it is that adolescent behavior, their decisions, and their impulse control begins to get compromised? And to do that, we really need to look at situations that we know they're very sensitive to. So this whole self-control is very important in the context of suppressing or inhibiting actions you're not supposed to do, but ones that are in the context of actions you do want to go towards, like eating the pie, or unfortunately experimenting with drugs, or going on the joyride, accelerating when they should stop the car when being pulled over. But what's interesting, when we just look at how social cues, or let's just take incentives, how they change our behavior. We had a little bit of a discussion about consciousness. So I want to use this as an example. Even without your conscious awareness, if every time you saw me and I gave you chocolate and you were a big chocolate hound, you would come to associate me with positive outcomes. And you might even, when you come to a meeting like this, approach me before you would another colleague. So let me show how that looks on a data slide. If you associate certain pictures with different amounts of money, so that each time the individual correctly detects a stimulus, if it's associated with a large reward, over the course of the experiment, you get faster and faster whenever you see those pictures. If it's associated with very little reward or none, you actually see significantly slower responses. So none of these individuals in the experiment could actually articulate which pictures were associated with the larger rewards, even though some of them had this general feeling that there were some of these associations. But that's very important in terms of how that can pull our behavior. What's also important is when we go and we look at where in the brain do we represent these incentives, that we learn about the emotional and really reward component of these types of pictures. And when we look in the brain, we see these deep structures that I showed you in the glass brain that are primitive, and they've been there for a while. And what we see across development is that adolescents activate these regions more than do children or adults. And I think it's interesting and important to point out even more that they activate this relative to young children. Now, this is a result that is fairly robust across numerous labs, both in the United States, but also in Europe and the Netherlands. This is just showing you the amount of activity in the same area when receiving rewards in adolescents relative to children and adults, and also in other labs in the States. Bayal Luna in Pittsburgh has also shown just even in anticipating a reward, you see greater activity in adolescents than you do in adults in this deep ventral striatal region. And more importantly, when we think about this with regard to criminal activity, the greater activity in this region, the more risk-taking that we see. So that those individuals who are activating this region more are more likely to engage in risk-taking behaviors. But this is just with monetary cues. And a lot of the criminal activity, and really how it differs from adult crimes, is many of them are carried out with peers or in social context. So what is social cues in the environment? How do they influence our decisions and our behavior? We can just simply look at how well you're able to stop yourself when you see a smiling face. And believe me, when you give these talks, right, there's certain people who are smiling who you're drawn to, even without being consciously aware of that. But how does that impact impulse control? So now let's give individuals this whack the mole task, but now what we're saying is, and don't press anytime you see a happy or smiling face. And if we look at behavior, then what we see is during adolescence, there are many more times that they go when they're not supposed to, so they're making more errors to these positive social cues than either adults or children relative to neutral ones. So they can easily detect the difference between these cues, but when they're told not to go, it's as if they're pulled and compelled. And not surprisingly, based on the previous research that I've shown you, the area that maps on to this behavioral performance is actually this area in the ventral striatum, this deep structure in the brain that's so important about learning the reward value for different cues in the environment. It's elevated in adolescents, not so much in children and adults. But it's not just incentives that can really pull a teenager into doing something they know they're not supposed to do. So it also appears that they're drawn to danger. When we simply present threat cues to them, such as a fearful face, and we look to see how well they can stop themselves when they have this rare cue occur, we see the same pattern. We see that they're drawn to these social cues, and again, they're making many more errors than the adults. If anything, the children are completely withdrawing from these threat cues, no tendency to respond to them. And if we then look at the brain and the area that's correlated with this behavior, we see this exaggeration here in a deep emotional center of the brain. Here it's the amygdala, and this was an area of focus that Jeff mentioned when he was talking about psychopathy, where there was dampened response in this area. And basically what we're seeing here is heightened activity in the adolescents relative to children or adults. But these are just simple laboratory cues. What if you actually have a peer with you when you're engaging in a task in a laboratory? And Larry Steinberg has really been wonderful in trying to come up with laboratory experiments and settings that mimic more what's going on in the real world. And he uses this really simple driving task where the individuals are repeatedly presented with intersections with yellow lights. How many of us tend to go or stop? So he basically, you have to make a judgment based on where you are, how close you are to that intersection, as to whether or not you're going to go through it or you're going to stop. And this is just showing you, here's the intersection, the yellow light, and then here you successfully went through the intersection, but sometimes you make risky choices and you crash. Now, the beautiful manipulation that Larry had in this experiment is not just to look at these risky decisions, do you go or do you not go, but is to have peers present when you're making those decisions as opposed to peers not being present. And adolescents and adults don't differ in their ability to perform this task when there's no peer present. But when they're next to them and they're playing the game, what we see is they're making many more risky choices, they're just barely making it through the intersection, and they're also having many more crashes. So they go even though they get hit by the other car. And then at this point, not to beat a dead horse, but I do hate that expression, you're not going to be surprised by the brain area where he actually sees discriminating between when you go and don't go across the age groups with the peers present, and it's this area in the ventral striatum. So what I tried to do is provide examples of how teens as a group have difficulty making the right decision and controlling their impulses in the heat of the moment. However, in cool situations, the simple go, no-go task, many of our adolescents would perform better than some of you did today. And this is very important when we start to separate out when an individual can make a decision, when they be less capable or have more diminished ability to guide their decisions, as opposed to when they can make one when they have plenty of time to think about it, such as decisions that an individual might want to make about their body without parental consent. And what I've also tried to show is not only the behavioral data, but potentially why adolescents' decision-making is impaired during this period of time because of this tension or imbalance in the development of these systems that aren't communicating well during this period of time. And then finally, that this diminished self-control, just as the inflection that we see in criminal activity then begins to drop off, so too do we see this capability of self-control increasing with age, so that it's more transient. It's not something that's permanent, and that's very important for us to keep in mind. And I'd like to just end by saying there's a special issue this month that covers much of the material that I'll point people to if they're interested. And thank you.